Hello, dear students. Welcome back to our discussion on air conditioning. Now that we have moved on to more and more into the air conditioning process, now let us try to represent various psychrometric processes in our psychrometric chart. So, the various psychrometric processes means the various air conditioning processes. When mainly we can the air conditioning or psychrometry deals with the study of dry air and the water vapor associated with that. Okay, so suppose there is a reference point like O, like this represented on the psychrometric chart. Suppose we are having a process represented by the line O to A. Suppose there is a process represented by the line O to A. What does this represents? O to A. Suppose a psychrometric process is represented by this line O to A. That will be representing what? There will not be so this will be a horizontal line O to A. So what does that mean? There is no increase or decrease happening to the humidity. But what is happening? There is only change in the dry bulb temperature, or there is only increase in the dry bulb temperature. So it means there is only heating is happening in that psychrometric process. So in a way, O to A will be suppose there is a line O to A in the psychrometric chart. This line will be representing sensible heating. Sensible heating means there is no phase change happening and there is no humidity change happening. Okay, only if there is any humidity addition or removal is happening, then only there will be a latent heating or latent cooling will be happening. Okay, so O to A simply means there is only heating. That is, we are simply heating the dry air of the atmospheric air. We are not adding or removing any water vapor content. Same way, if there is a line like this O to B towards left, okay, horizontal line drawn towards left, O to B simply represents a decrease in the dry bulb temperature, of the moist air. In this line also, when we are considering this line O to B, there is no increase or decrease happening to the specific humidity. So there is only sensible cooling, or we are simply that is the line O to B represents the sensible cooling, that is the simple cooling of the atmospheric air without any change happening to the water vapor content or the moisture content. Then we can have another line like this O to C. Suppose there is a line O to C like that. What does this line O to C represents? O to C represents a decrease happening to the amount of water vapor content, or this line O to C represents a dehumidification, or the humidity is getting reduced, or dehumidification. So if you observe this line O to C, there is no increase or decrease happening to the dry bulb temperature. So there is no heating or cooling. It is simply dehumidification alone. So this line O to C is representing dehumidification. Same way, if you draw a line vertically upwards from O to D, O to D represents humidification process. That is, there is only increase in the humidity content. There is no change happening to the dry bulb temperature. So this line O to D represents humidification or addition of water vapor content or addition of humidity. Then suppose we are having a line like this O to E. That is, there will be both increase in the dry bulb temperature as well as there is increase in the humidity content. So O to E represents heating and humidification. Okay, so O to E will be representing both heating and humidification. So suppose we consider a line just opposite to OE, that is in terms of OF. So this line OF, it simply represents both cooling, because dry bulb temperature is decreasing, and at the same time dehumidification, because the omega value or specific humidity is decreasing. So O to F is representing cooling and dehumidification. Okay, then another line O2G. O2G, it is very clear that the tribal temperature is decreasing, at the same time humidity is increasing, so it will be cooling and dehumidification. Okay, so O2G will be representing a process cooling and humidification. So if you draw another line just opposite to OG, so it will be in the direction O2H. So O2H represents both decrease in the humidity content as well as increase in the tribal temperature. So O2H is a will be a process representing dehumidification as well as heating. So it will be a combined process of heating and dehumidification. Okay, so all these processes, heating, cooling, dehumidification, humidification, combination of heating and humidification, or cooling and humidification, etc., all these processes will be encountered in any practical air conditioning process. Okay, so depending upon the customer requirement, we may have to design our air conditioning equipment to provide these processes. Okay, then another term associated with this air conditioning is called sensible heat load. Okay, that is, we have here discussed the line OA and OB, that is simply sensible heating or cooling without any change in the latent heat content or without any change in the water vapor content. So sensible heat load means whatever heat load is present in the moist air which is meant only for heating or cooling there, or we are not considering the addition or removal of water vapor. So worldwide scientists have experimented with this air conditioning and they have brought out a empirical formula for quantifying this sensible heat load, represented by QS is equal to 0.0204 cmm times delta T. This quantity will be in kilowatt. So this delta T variable will be the change happening to the tribal temperature. Cmm will be the cubic meter or the volume flow rate of the moist air. Okay, so you just understand that there is a empirical formula like this. Then just like the sensible heat load, there will be a latent heat load. Latent heat is mainly associated with this phase change, or mainly when we are considering this moist air, the mainly phase change is happening to the water vapor. More or less there will not be any phase change happening to the dry air or the vapor form of air, but the phase change will be mainly happening to the vapor form of water, or the water vapor may either get condensed, or water vapor may get added to the moist air. So that will be addition, that is addition or removal of water vapor, or in other words humidification or dehumidification is the main latent heat load. We are not considering heating or cooling the air, that is the increase or decrease in the tribal temperature is not considered when we are considering the latent heat load. Just like this sensible heat load, for calculating this latent heat load, another empirical formula was put forward by the scientists, the psychrometric scientists. QL, representing the latent heat load, L stands for latent heat load, is given by 50 times the volume flow rate in cubic meter per minute cmm times delta omega. That is, here you note the change happening. It is not delta T was for the change in the tribal temperature, and that was giving us the sensible heat load. Here for the latent heat load, we are not considering the change in the tribal temperature, but we are mainly focusing on the change happening to the content of water vapor. Is there any humidification or dehumidification happening? That is the delta omega. This value will also be in kilowatt. Okay, so the total heat content of a moist air will be the sum of the sensible heat load and the latent heat load. Okay, so when we are considering a particular amount of moist air or atmospheric air, it will be containing both sensible heat load and a latent heat load. That is, the sensible heat load will be with respect to simple cooling or heating of the air, while the latent heat load will be represented by increase or decrease in the water vapor content. Then with respect to this discussion, let us consider another important term called sensible heat factor or SHF. It will be the amount of sensible heat as a percentage of the total heat content, or QS by QS plus QL. Sensible heat factor is a how much percentage of the total heat load is the sensible heat load. Okay, so suppose how we can represent this sensible heat factor. Sensible heat factor can be very easily represented on the psychrometric chart. Suppose there is a psychrometric process from 1 to 2. Any process, any sample process, sample process we are considering, for example, suppose there is a process from 1 to 2 in the air conditioning equipment. So what is the how we can find the sensible heat load? Sensible heat load is mainly associated with the temperature change or the dry bulb temperature change. For finding out the sensible heat load happening during the process 1 to 2, what we can do? Find out the temperature change happening, or find out the delta T, or find out the dry bulb temperature change happening during 1 to 2. For that, what we need to do? Simply drop a perpendicular towards this dry bulb temperature axis from 1 and 2. From 2, drop a perpendicular. From 1, also drop a perpendicular. So we will be getting a temperature change happening from 1 to 2, or what is the dry bulb temperature change happening from 1 to 2, or this delta T is proportional to, or it is representing the sensible heat load. Okay, then what is the latent heat load present during this process 1 to 2? That will be with respect to the delta omega, or the change happening to the specific humidity. How we can find out that? Simply draw a horizontal line from 1 and 2. Okay, so these horizontal lines from 1 and 2 will be finding out the delta omega, or change happening in the specific humidity, and this delta omega will be proportional to the latent heat load. Okay, and this delta T change with respect to the total heat change will be giving us the sensible heat factor. So suppose H1 is the enthalpy at enthalpy of the moist air at 1, and suppose H2 is the enthalpy content of the moist air at 2. H2 minus H1 will be H1 will be the total heat content, or the total heat load present during the process 1 to 2. Okay, H2 minus H1. Out of this H2 minus H1, how much will be the sensible heat load? For that, we have discussed that we are drawing the perpendicular lines and the horizontal lines. These perpendicular lines and horizontal lines will be intersecting at a imaginary point A. Okay, please note that this point A is an imaginary point. Actually, this is not a part of the actual process 1 to 2. Okay, so this imaginary point A, after locating this imaginary point A, simply find out the enthalpy value corresponding to A, that is HA. Okay, so HA minus H1 will be the sensible heat load, and also H2 minus HA will be the latent heat load. Okay, so HA minus H1 divided by H2 minus H1 will be our sensible heat factor. Okay, so with this idea, let us move on to the next discussion. So you please you please try to understand this sensible heat factor, and how we can represent this sensible heat factor on the psychrometric chart. So thank you.